Okay, hi 3E. I think many of you have feedback that you have difficulty completing this Notes 7C. Alright, so I'm doing this video so hopefully it can help you to solve the questions. Alright, so learning outcome will be to solve simple practical problems in 3 dimensions, including those involving angles of elevation and depression. Alright. Okay, I think you can go through this on your own. Investigation 1 and investigation 2. Basically, let's focus on how to solve 3-dimension problems. Okay, how to solve 3-dimension problem. First, this is very important. Reduce the problem to a simple plane. That means draw a simple diagram in 2 dimensions, basically a right angle triangle. Okay, so in the question you need to look for relevant right angle triangle, then sketch it in 2-dimension form. Okay, in 2D form. What to apply? Most of the time you apply Pythagoras theorem or Torcaso because they are right angle triangles that you have drawn out. Okay, in some cases when there are non-right angle triangles, then you will be dealing with sine rule, cosine rule, or maybe area of triangles. Okay, as mentioned here, sine rule or cosine rule. Okay, so make sure you can remember sine rule, cosine rule, Torcaso, and Pythagoras theorem before you attempt this Note 7C. Very quickly, example 1. Okay, you're supposed to look at this cuboid and identify all the right angle triangles. The right angle triangles are given on the left. Then you need to state which is the right angle, and after that sketch the right angle triangle in 2-dimension form. Okay, the cuboid on the right side, they are all in 3-dimension form, so you're supposed to sketch it in 2-dimension form. Okay, let's start from the question 2. They want triangle DEH. So try to find where is DEH. It's somewhere here. Where's the right angle triangle? It's here. So where's the right angle? Right angle will be DHE. DHE. Here. Okay, so you're supposed to draw it out. This is E, this is H, this is D. If there are numbers allocated to the sides, then you just update the numbers as well, the length. Alright, next question, BDH. From the next diagram, BDH, triangle BDH. So it's a triangle that cut through the middle of the cuboid. Right angle will be here. So I will say BDH is a right angle. Then let's draw the right angle triangle. D is the right angle, H and B. That's all. Now triangle ABD. Where is ABD? Oh, ABD is lying flat on the ground. ABD. So where's the 90 degree? It is here. Okay, when you are drawing on a 3-dimension diagram, the 90 degree will not look so nice like a square. It will not. Okay, it may be slanted. Okay, or like what you see on a diagram. So for ABD, the right angle is at A. So in particular is DAB. Okay, angle DAB. Draw the yellow triangle out, triangle out. So it's DAB. Last but not least, the last figure. If this is too fast, pause the video and try to catch up. Okay, last figure. Triangle AEG. So in the question, they will tell you which triangle to focus on. Okay, one sentence, they will say, hey, this triangle, you have this length, this length, this length. If you want to find the length of a particular triangle, and then you draw out that relevant triangle. Okay, so where is the right angle? It's at E. Alright, so it's AEG, angle AEG. AEG. Since the triangle is this way, I will draw a two-dimension diagram. E here, oh sorry. A here, then G here. Okay, AEG. Okay, need more time, please pause the video. If not, I'll proceed on to question 2. Example 2. Okay, let's look at example 2. We need to draw out the two-dimension figure. Alright, for every question, I hope you can try on your own. Only when you find difficulty doing, then you watch this video. Okay, so all the information are given. Find length BD. Where is BD? Let's draw a line to find BD. BD is somewhere here. I don't have a ruler, but for your case, please use a ruler. BD is here. Which relevant triangle should I use? I will say, since I have the length 6, since I have the length 8, so the relevant triangle I'll pick will be ABD. Right angle will be at A. So I'll draw out this triangle. Okay. A is here. D is here. B is here. This is 6. This is 8. This is what I call the two-dimension diagram. This is three-dimension diagram. Alright, so pull out the triangle and I can find length of BD. BD square equals to 6 square plus 8 square. This is Pythagoras theorem. You get 100. So BD equals to square root 100. Don't have to put plus minus because this is we're talking about length lah. Okay, length is definitely positive. So I get 10 cm. Part B. I want to find angle DBH. DBH. Maybe I'll try using a different color. DBH. Oh. So I will need this. DBH. So I'll focus on triangle DBH lah. Which angle is right angle triangle? At D, right? Here. So let me draw out the two-dimension figure. At D, this is H, this is B. Okay, I do have the length, the height of HD. It's the same as EA. I do have BD from the previous part. It is 10. I want angle DBH, which is this. Let's call it theta for convenience sake. So now what do I have? I have the opposite of this theta. I have the adjacent of this theta. So it must be toa. Tangent. Toa so tangent. Tangent theta. Theta is what I want to find. Angle DBH equals to opposite over hypotenuse. Theta equals to tangent inverse 5 over 10. I get 26.565 for 5 significant figure. Final answer 26.6 degree. 1 decimal place. Alright, if it's too fast, pause the video. If not, we'll go on. Next question. The diagram shows a cuboid with some dimensions given. Look carefully the dimension, because sometimes it may be a bit tricky. Where is the 6 cm? Where is the 8 cm? If you misread the question, the whole thing will be wrong. Now I want to find length AH. Okay, pause the video, try on your own. If you're stuck, then watch the video. I want AH. Let me draw AH first. AH is here. What information do I have? I have the 5 cm, I have the 6 cm. Oh, okay. Maybe I'll focus on EAH. How about that? EAH. Then this is a 90 degree. So let me draw out EAH. Because I know the height is 5, this is 6. So I can apply Pythagoras theorem. AH equals to, let me go faster, AH equals to 5 square plus 6 square, and you square root. Okay, let me go faster. So this will be square root of 61. It is actually 7.8102, but I will round off to 3 significant figure. 7.8102, 5 significant figure may be useful for the next part. Let's see, the next part. Angle GAH. Let's locate where is GAH before we draw the triangle. Every question we try to draw a triangle. GAH. Oh, okay. GH is here. I use a different color. GH is here. GA is floating diagonally. Then AH is the red line. So it will overlap. AH is the red line. Overlap. So where's the 90 degree? Yes, if you say H. Okay, so I draw H here, G here, A here. What length do I have? AB is 8, so HG is also 8. AH I've just found. Don't give me 3SF, give me more. 7.8102. Can I find GAH now? GAH is here. Can I find it now? Let's call it theta. Can it's a triangle that is floating in the middle of the box. So I want to find this particular angle. Once I draw the two-dimensional diagram, it should be much easier compared to compared to just focusing on the 3D diagram. So the number 8, is it opposite or adjacent? It's facing theta, so it's opposite. This is adjacent to the angle. This is adjacent to the angle.
Using this place?
2 minutes. Give me 2 minutes. Finishing. Yeah. Alright, so this is adjacent. So I will use tangent. Tangent theta equals to opposite over adjacent, 7.8102. Theta equals to tangent inverse, 8 over 7.8102. And I have 45.688 for 5SF and 45. Sorry, I shouldn't say 5SF, I should say 3dp. Then 45.7 for 1 decimal place. That's the final answer. Okay, I'll pause here now. You can watch the next video for example 4, 5, and 6.